Draw a force diagram assuming the box is moving. Is this box? Oh yeah. Is this the furniture one? So there you go. With this 35 degrees below horizontal. F sub n like this. F sub f like that. Cracking this. And of course putting gravity here. And this one being Fa, this one being Fx, this one being Fy. And of course, I would put V constant like this so that I remembered. Then what is mu? So then here, I just write it all down. Some of the forces in the x are 0. Some of the forces in the y are 0. So in the x, we have Fx minus Ff equals 0. In the y, we have Fn minus Fy minus Fg equals 0. Where is mu? Mu is in Ff. So I'm going to go ahead and substitute all this stuff together. This is going to say Fa sine theta is equal to mu F sub n. Over here, I'm going to solve for F sub n so that I can substitute. Fn is equal to Fa cos theta. Oh, wait, that's not right. Just kidding. Let me fix that. See, based on my triangle, if this is 35 right there, this should have been cos theta, and then this one is sine theta. Okay, and then plus mg. Now I can sub, so I have Fa, well actually, you know what? First what I'll do is I will just solve for mu first. So I'll say mu is equal to Fa cos theta over Fn. And what is Fn? Fn is this stuff. So I get Fa cos theta over Fa sine theta plus, supposed to be a g there, plus mg. And this gives you a mu, I think, of 0.271. Is it a 2? There's no 2's in here anywhere, except for right there. Okay, again, you don't have to completely worry about writing everything down because this is going to be online and I'll check it before I go today to make sure. Any questions so far? So the best thing is to sit back, absorb, and think. That way you can write it. You can write it down later if you need it. Yes.
When you're solving for mu, how do you get the number from the Fa cosine?
Oh, well, you know what Fa is, right? So if I go ahead and write this out, oops, that's not a good color. Let me write this in red. Mu is 140 times the cosine of 35 over 140 times the sine of 35 plus 35 times 9.8. Yeah. Okay, any other questions? To be honest with you, I feel like this is a little bit too complicated. I think this one, like this much work, will be down here. This is going to be a little bit of work, but not that much. Yeah.
Wait, so the Fn, you just replace the F1 and Fg with okay.
Because see how like F up equals down, right?
Yeah.
So Fn equals Fg plus Fy. So that's what I got right here. This is Fy, this is Fg. And then I just substitute it in for wherever Fn is right here, and that's that right there. Okay. So now we go down to here. All right. So starting from rest, if you push with a force of 170, so now we've increased the force. If you increase the force, you can't say it's moving at a constant velocity anymore, right? I mean, if you push harder, something's probably going to happen. So we have to do the whole, like the force statements again. So I still have, in the x, I'm still going to have fx minus ff, but now it's going to equal ma instead of 0. Does that make sense to you? Right. Before, it was moving at a constant velocity. If you're sliding something across the ground and it's moving slow, you push harder, what happens? It goes faster, hopefully, right? Okay, so now we've gone from a 0 here to an MA here. That's the main difference. We still have Fn minus Fy minus Fg equals 0. We still have that same thing.
What is it? Fy is alongside it.
Yeah, Fy is down because you're pushing down on the box. So Fy is down, parallel to Fg. Because you're pushing at an angle, but we can't take that. We have to crack it. So we get X in the horizontal and then Y down.
And why is it all subtraction?
Oh, because what points up? What points down? And
And that's why.
So Fn is
if they're in
positive.
the opposite directions? Yeah, go ahead.
So Fn is positive and Fg and Fy is negative.
Oh, okay.
Okay, so what is your velocity? Okay, so in order to get our velocity, we need to get our acceleration, which is right there. So our acceleration is going to be fx, which we already know to be fa cosine theta? Cosine theta minus ff over m. Now I know this, and then, well, I'll do that down there. And we know that fn is equal to fy plus fg. So then a here is going to equal fa cos theta minus mu f sub n all over m. Well, that means fa cos theta minus mu times fa sine theta plus mg all over m. Because look what I did. I took this and I stuck it into Fn. And I went ahead and in here, I put Fa sine theta, and in here, I put mg. So 175 cos theta times the cosine of 35 minus 0.271 times, oh wait, I know. How heavy was this, 35?
Yeah.
Okay, and I get 0.663 meters per second squared. And now I just use V is equal to V0 plus AT, and that's going to give me like 13.3 meters per second. Then the question says, if the box is released, how far does it slide? Well, we have to do another, I'll do this in a different color so we can kind of see. We have to do another mini force diagram of a box that is sliding. V is this way. Fg goes down, Fn goes up. What's the only force affecting a box sliding across the floor? Friction, which is going to go backwards. That's F sub F. So I do the sum of the forces, and the X is equal to ma. That's going to give me negative FF is equal to ma, right? Which lets me get, or which gives me A is equal to negative mu F sub n over m. Based on this, do you see that F sub n is equal to F sub g, or F sub n is equal to mg? So that means negative mu mg over m. M's cancel, I get A is negative mu g. Does a negative acceleration make sense to you? It should, right? Because it's slowing down. If you push a box across the floor, Wouldn't it freak you out if it kept going forever? Or if it started speeding up by itself? Right? You would expect it, you push it, you expect it to slide to a stop. So we remember that our mu was 0.271 times 9.8. So that gives us negative 2.66 meters per second squared. So how far does it slide? We know the initial velocity is 13.3 meters per second. We know the final velocity is, what should the final velocity be? Yeah, 0, right? So we know the initial, the final, they want x. So I use v squared is equal to v0 squared plus 2ax. X is equal to v squared, v final squared, minus v0 squared, all over 2a. Vf is 0, so we get 13.3 squared divided by, 5.33 or something like that. And we get about 33.2 meters.